Hi everyone, welcome to chapter 16, which is all about fluvial processes. I'm going to try to do this chapter all in one video. It's not quite long enough to break up into two, so this video will probably be a little bit longer than most of them, but stick with me. So when we talk about fluvial processes, we're talking about the overland flow of water, which we most often think of as rivers, but we have other types of overland flow of water as well. So here we're looking at a picture of the Grand Canyon, which was carved out entirely by overland flow and by the Colorado River. And so we're going to talk about how that happens. So fluvial processes are basically flowing water. This flowing water weathers, erodes, transports, and deposits, right? So it weathers that rock, it removes it away, it transports it to someplace else, and it deposits it. So if we look here at this picture, right, we have it rained, water has flowed down. Here you can see the river, and then it's going to deposit it in these fans and floodplains. So we're going to talk about erosional landforms and depositional landforms that happen due to this flowing water. So again, makes erosional and depositional landforms. Fast-moving water erodes and slow-moving water deposits, which is pretty intuitive, right? If you have really fast-moving water, you're going to pretty effectively erode that landscape, and as that water slows down, it's going to want to drop that material because it's no longer going to have the power to keep carrying it. So when we talk about flowing surface water, we refer to it as overland flow. It's not necessarily in a channel, right? Regular overland flow. So here we see overland flow that is happening. It has rained and some of this stuff is being pushed down, but we don't have a defined channel yet. As opposed to stream flow, which is in a defined channel, which we can see right here, right? Enough erosion has happened that we have this really defined channel, and then we get a stream. So all of this overland flow is eventually going to make it into a defined channel or a stream, but and it can also form new streams in the future. Water basically finds the quickest path downhill. So as it finds that quickest path downhill and it erodes over and over again, you'll then later on get this defined channel. Water flows by gravity, always. It never flows uphill, ever, never, ever, right? Water is always finding its most effective and quickest path downhill. So I'm going to talk about something called basins and divides. So a drainage basin is an area in which all the water collects into a single stream. This is also referred to as a watershed. And so basically here you can see this line. This is a drainage basin. All of the precipitation that falls within this area is going to eventually make its way down into the stream. If it falls on the other side of this, it's going to make its way down into another stream because it's a different part of a different drainage basin or watershed. So divides are the high ground at the edge of valleys that water can't flow over. Remember, water never flows uphill. So water falls on this side of the line, it goes down to here. If water falls on this side of the line, it goes down there. Small-edge drainage basins are nested into larger ones. So when we think about the Mississippi River drainage basin, it's rather huge, right? All of this water will eventually make its way down into the Mississippi River drainage basin, but we can divide that up into smaller drainage basins, the Missouri, the Upper Mississippi, the Ohio, and here inside of the Missouri is the Yellowstone drainage basin. So you can really divide them up in different ways. You can divide them into one massive one or much smaller ones. Stream order is this idea that low order streams, or those beginning streams, happen on high, steep ground, and the water is moving very, very quickly. So this is where your highest elevation is going to be. These low order streams, this water is going downhill pretty fast. It is eventually making it into 2s, 3s, 4s. These high order streams happen on low, flat ground, and they're often slow, They're wide rivers. They tend to be meandering. All right, so all of these streams are eventually making it into here. So what you want to remember from this slide is that low order streams, those ones and twos, are on high ground. They are small, steep, and fast. And those high order streams are on low ground. They are wide, fat, and slow. And so when we look at huge river basins like the Mississippi Missouri Drainage Basin and the Amazon, which is a massive one here, all of these rivers could be numbered and eventually make it down. The numbers don't actually get that high before they meet up, but all of the water that falls within this area is eventually making it out of its way to the sea by the Amazon. We can look at drainage basins or watersheds in San Diego County. We can divide it into smaller ones. Here's the drainage basins for the Tijuana River, San Dieguito, Penasquitos, the San Diego River. So these things can be quite useful for planning and understanding how water flows. You might have heard the term before, the continental divide or divides. And so here's a picture of the United States. I'm sorry, it's not a very great one, but it's the best one that I could find. So the continental divide is this idea that everything on this side of this red line eventually makes it into the Gulf of Mexico or Atlantic Ocean, and everything on this side makes it into the Pacific Ocean. If you see this brown thing here, this area, this is the Endorheic Basin that we talked about before, where we have the Great Salt Lake and the Salt Flats, right? These guys don't have an exit to the ocean. We can talk about rivers in terms of discharge or how much water eventually reaches the ocean. The Mississippi River is not actually this wide. This is a thematic map that shows you the thickness of the river is based upon how much water it's carrying. Columbia also carries a lot of water. The Colorado River, we extract most of that water along the way, so almost no water reaches the ocean in the Colorado River. So we can erode the landscape by this overland flow, which again is that flow that's not in defined channels. And so in the early stages, you can get these many like tiny little distinct channels called rills, which are pictured here. This is actually taken by San Diego State, kind of near my house. You can see the water is finding the quickest path and kind of eroding it away. The channels widen and become fewer and wider paths. They become gullies. If you have visited Tijuana, to some of the streets that aren't paved in Tijuana, they have a lot of problems with gullies that happen, lots of erosion that has to go back and be filled in order to preserve that road. But paths basically keep getting wider and fewer over time until you will eventually wind up with a stream. And so here we can see overland flow coming from San Diego's canyons. Here's an aerial view. So this is the higher ground here, and it's water is flowing down into these defined channels. We have lots of streams in San Diego that are seasonal, so we don't have water in them all the time. We only have water in them during a rain event. If you've hiked any of the canyons in the city, which I recommend that you do, there's a great organization called San Diego Canyonlands that I've been involved with a lot, and they restore urban canyons and put hiking paths in them. There's a whole hiking trail that you can do in City Heights, but most people don't even realize that these canyons behind the houses can be accessible to the public. Stream erosion, so this is after you get that big defined channel, happens in a couple of ways. The first is by hydraulic action, which is the force of that water eroding things, pushing things together, bouncing it around. You also have abrasion, where you have sediment or that stream load, which is as it's referred to, scraping along that channel. And so the more discharge, the more water, the more power to erode and transport. We're going to talk about stream profiles. And so we can have an ungraded stream that goes to a graded stream. So ungraded means that you have these steps, right? So you have a stream here, and all of a sudden it falls down via waterfall, and then you have it's flowing kind of over a relatively flat landscape, ultimately to the sea level, as opposed to a graded stream. As opposed to a graded stream, which is just flowing downhill all the way. So here are your low order streams up here and your high order streams. So as your stream flows downhill, eventually it's going to become flatter and wider. So the bottom of the Mississippi looks very much like this, very flat, meandering river. And so those lower order streams, right, those ones that occur at higher elevations and they are very steep, erode in their own specific fashion. They do that by down cutting. So again, you have these high gradients, this dramatic change in elevation. You have really fast moving water. You can see the waterfall right here. And so you wind up getting these deep, steep-sided valleys, right? It's that down cutting is basically cutting into the landscape like a knife. And so these very, very steep valleys on either side. They tend to flow in straighter paths too, because they are really just being, they're primarily pushed by gravity. So they are going to flow pretty straight. We also get something called Knick Point migration. And so this is how kind of a waterfall moves back over time and erodes. So a Knick Point is an abrupt change in elevation along a stream, usually kind of results in a waterfall here, you can see. And what happens is over time, this is coming down, it's eroding underneath, and then that Knick Point is going to collapse. That overhang cliff is going to collapse. And so now this waterfall has been pushed back. And that waterfall then moves upstream. So Niagara Falls are constantly moving upstream. We can see evidence of them really, really far downstream. And eventually they will make their way all the way into the Great Lakes. And this is repeated many times over. We also have something called headward erosion, right? So here we can see this is from Canyonlands National Park. We have these kind of fingers that are coming in, and as water flows down into this canyon, these fingers are going to lengthen and erode away this landscape. The faster the water, the more erosion. So as it goes off of this cliff here, it's going to erode much faster than it is going to back here. So those canyons and valleys become longer over time. And again, a lot of this erosion, we can see it happening, but to the point where these canyons are really going to push back. This is again over very large time scales. So again, Niagara Falls you can see Knick Point migration and headward erosion with Niagara Falls. And so Niagara Falls used to be much farther downstream, but this area is constantly eroding away. So right now here is the Niagara Escarpment, which has pushed back. The falls are about here now. The falls will eventually get all the way back into Lake Erie and then disappear. So those falls are going to keep moving upstream. It's going to create this gorge, which we can see here where they used to be as it retreats. In 23,000 years, there'll be no more falls. There'll just be a gorge and a river that comes out of Lake Erie. And so then after that, after you get these falls that move all the way back into Lake Erie, that river will start to meander and meander more and will erode this entire escarpment away. And so that's what happens with those high order streams. You get this meandering erosion, which we'll look at in a minute. So here is this channel erosion by high order streams. So basically you have this flow of water over flat ground. And so you can tell those high order streams because they're on flat ground and they're meandering. And they're slowly eroding away this gorge. They're slowly eroding away the sides. Many meanders in a river that will change over time. This is an oxbow lake, which we'll talk about in a second. The outside of the curve right here, you have faster water flow. This water has to go a greater distance than this water does on the inside of the curve, and therefore it has to flow faster. And so you get something called cut banks, right, where it's cutting into the side. Here you can see a cut bank where it's actually eroded away, and now you have this structure that's going to have to be taken down. Inside of the curve right here, you're going to get a depositional landform. That water is going to be flowing more slowly, so you're going to get something called a point bar. You're going to get new land that is being formed by that sediment that's being dropped off. And so in this picture here, you can see here is the point bar, right, where it's been deposited. This is the old cut bank. This is the new cut bank where it's being eroded away. So eventually this curve is going to make its way. It's going to cut farther into this. This point bar is going to get wider and wider and will eventually become vegetated like it is there. And so when we have these high order streams, we get something called lateral erosion, right? It is flowing back and forth, back and forth. It's depositing sediments here on this flat landscape, and it's eroding the cut bank here. And so that river is flowing through what's called the floodplain, which is surrounded by bluffs on either side. Water is always basically trying to flatten out the landscape. So the water is going to flatten out the landscape, and the way the landscape rises up again is through some type of tectonic activity, and then the water is going to erode it away again. So that valley is going to get wider over time. And river changes course frequently, right? It carves into the bluffs at different places at different times. That water is always trying to find the most efficient way out to the ocean. So rivers change their course constantly and sometimes really dramatically. And so this Oxbow Lake here is where the river used to flow. This was cut off and now is a lake. And this lake, because it's not being recharged by this river again, will eventually dry up. And so we can see here, here's the Trinity River in Texas, and here is a recently formed Oxbow Lake. And so here we have our river is flowing, it's doing its meandering thing. Eventually the water finds a easier path through, and so it doesn't need to go through this meander anymore. That gets cut off and becomes an Oxbow Lake. That Oxbow Lake will eventually dry up and will be called what's called a meander scar, right? We can see where that river used to flow, but it doesn't flow there anymore. So the stream finds a quicker path through that meander. And that meander is cut off and forms an Oxbow Lake. And it can happen very quickly and often. It tends to, now that we develop and we kind of manage lands, they used to happen a lot more frequently than they do now in areas where a lot of people are living because we've built structures there and we don't want that river to change. And so here's Carter Lake here's the border between Nebraska and Iowa, right? The border between Nebraska and Iowa is based upon a historic meander in the river, but the river no longer flows here. And so a lot of our state boundaries were made based upon river meanders that are no longer there, that have changed. So you get these kind of crazy looking borders that don't necessarily represent the current river or the current actual border. And so you can see here, here is Mississippi, here's Arkansas. This dashed line is the border between the states, right? And so this follows kind of the historic meander of the river when the state lines were drawn. But now here used to be an Oxbow Lake. Well, there's actually Midway Lake is right there. This was a meander scar. We can see a really nicely defined Oxbow Lake here, but now the river flows this way. So this is how you wind up with a lot of kind of crazy state boundaries, and not just state boundaries, but international boundaries, where the original boundary was based upon the natural feature of the river. And if you look at, this is the Mississippi River, kind of the historic meanders of the Mississippi River. It's crazy. They're changing all the time. And again, we manage a lot of this now so that this doesn't happen to this extent because we've built a lot of this. There's something in the United States called the Wild and Scenic River Act, which some rivers, very few, are allowed to do their flow, and we're not allowed to mess with them at all. The Merced River that runs through Yosemite Valley is part of the Wild and Scenic Rivers Act when it runs through the valley. So when that river changes course, the people who are managing Yosemite Park just have to deal with that new meander. They can't try to direct the water at all. And so here we can see some satellite footage. I'll play it again. So here we're going to watch, the river is going to connect here, and there's your meander scar, right? So here is an area in South America where it's not being heavily managed, so the river is kind of being allowed to do what it's would do naturally, and those meanders are going to constantly change. We're going to talk about stream rejuvenation. And so those meanders are usually seen on flat ground, right? And that flat ground can only be rejuvenated by tectonic uplift. So here's what it looks like in the beginning. It's mature, it's been uplifted. In old age, this river has flattened out this whole landscape, and then the landscape is then rejuvenated by tectonic uplift, and that's how you wind up with these deeper rivers. So that Susquehanna River that I talked about previously, right, that river was here before the tectonic uplift. So then the stream now has new stuff to cut into. The river has new ground to erode into. So that can lead us to have something called entrenched meanders. You can see them really well in Utah, right? You have this very flat area where the river was flowing, there was a tectonic uplift, and now you have these very deep streams. And this erosion will continue to happen and erode away this landscape, but that's how you wind up with these cliffs kind of on the side of a river of a high order stream. The last thing we're going to talk about in this chapter is flooding. And so flooding happens pretty intuitively when there's too much water for a stream channel to hold. Here's the Red River in North Dakota that flooded. All rivers flood occasionally. They have something called a recurrence interval. You might hear this is a 100-year flood, or if this is the 500-year flood. And that's basically about the amount of time it takes for that river to kind of flood, or at the interval at which it happens. Climate change is messing with flood intervals, and so now people are worried that those flood intervals are going to shorten, or you're going to wind up with more extreme floods due to there to being overall more precipitation. These floods create depositional landforms. As the river breaks its banks, it's going to drop all types of deposited material here. If you've ever lived through a flood, you know that when that water recedes, right, it leaves just a bunch of stuff behind with it. It can also be very devastating because you can imagine it's also picking up a lot of what was on the ground that you don't necessarily want in your water supply, oil and gasoline from these cars, stuff that's in the sewers that it's getting mixed in with. So a lot of times this water can be very, very toxic. We also have something called flash flooding. You're going to watch a video of a flash flood after you watch this chapter. And so you'll get a rain event that happens pretty far upstream, and a flash flood will come downstream pretty quickly and carry lots of debris. They can look like not that big of a deal, and you can get in a lot of trouble with them. Especially there will be people who are hiking in canyons that have some type of stream flow. There'll be a rain event that happens upstream. All of a sudden, water will come rushing through that canyon very, very quickly, and people will frequently drown from them. So when you're in a hiking situation in an area where flash floods can occur, it's very important to understand what the weather is happening and to know about rain events that are occurring upstream. We in San Diego, the San Diego River frequently floods Mission Valley. Big one in 1980 1980 and 2010, this Qualcomm Stadium, much around that area flooded. I've seen plenty of flooding in there. Fashion Valley Mall's parking lot, don't park in the bottom if it's been raining a lot, because that will frequently flood. But we have developed very heavily in a floodplain of the San Diego River, which can lead to lots of problems down there. And so when flooding happens, we're going to get those depositional landforms. Floodplains are that flat area that's at the end of the river. You're going to watch a video about the kind of disappearing shoreline of Louisiana, because the Mississippi is no longer allowed to kind of flood that area and deposit all of that material anymore. So a lot of the shoreline is rapidly disappearing. But basically, all of this soil and sediment that was carried down by the river eventually fans out and is deposited and kind of makes new land, and also prevents a lot of erosion. And those are called river deltas. And the velocity is slowest at the river's mouth, right? So it's really going to drop all of that stuff off. River is at its slowest point, and it can no longer carry that sediment any further. And that river is constantly searching for quicker paths. So basically, the Mississippi River, if it was allowed to kind of flow how it would do naturally, it would kind of be going back and forth and depositing material all around the delta. So it deposits new land in this kind of fanned shape formation. We also get something called levees. And so, that got cut off. This is the raised banks of material on the side of a river. Sometimes it's natural, sometimes we deposit stuff there. We build levees in order to keep a river in its place and for it not to flood. It helps controls flood in their natural state, but they need constant maintenance, right? And if these levees break, you could tell this area was dry, now it's completely flooded, because water always wants to find that quickest path. So that is the end of this chapter. There's several videos for you to watch in this chapter, including one about levees. And so I will see you back for the next chapter.